Hi, folks. Welcome back to another episode of ThatOneSecGuy's podcast. Today, we're deep diving into the fascinating world of fuzzing, a powerful technique for uncovering hidden vulnerabilities in software. Joining us on this mission, we've got the legend himself, Mr. Zero Day Discoverer, and my good friend, Mr. Dheeraj Mishra. Talking about Dheeraj, he has been a very active guy in the realm of offensive security by discovering multiple zero days in modern web browsers. He's a frequent speaker at top security conferences like blackhat and BruCon, and is a passionate contributor to open source security projects. Dheeraj, welcome to the show.
Thank you. Thank you very much. And thanks once again for having me and for the great introduction.
Lovely. How are you feeling today?
Great. Can't complain. Going on. It's UAE. So, we are at the peak of how hot the weather is right now. But yeah, I'm
Of
suffering
course.
from cold. So you can see maybe the jacket or something. But yeah,
Okay. Okay.
great.
I hope you recover soon.
Yeah, likewise.
So, folks, we are going to be touching upon fuzzing. So let's get started in it, right? So just to set a context, uh, think of a house which is locked and you can enter it only by opening the lock with the right key. So, in my layman understanding, Dheeraj, fuzzing or fuzz testing, in essence, throws a bunch of random keys to the lock, hoping to find one that breaks it, but in a controlled way, of course. So, Dheeraj, if you could tell us what is fuzzing exactly, because you're the expert and you've been doing this for a long, long time, and how does it offer a more comprehensive approach to software testing in comparison to traditional methods?
Got it. So I really got a great example in a very layman term right now. So I'll just maybe just put in that. So every person right now, in some or the other way, they are doing fuzzing. Let's suppose an example. If your salary gets credited, or probably if you're doing a math of two numbers, right? So suppose we do 2 plus 2. So ideally, those 2 plus 2 are just numbers, but you're doing an addition of it and you
Hmm,
expect an output out of it, right? Which
hmm,
is like a 4.
hmm,
Now, in general, when a normal people or a normal layman guys, when they do this addition, probably the output for them would be like a salary or maybe, um, the hype of whatever they are doing. But in general, that is nothing, just a magic bytes, right? Because it can be a profit, it can be a
hmm,
loss, or whatever it is.
hmm,
So in fuzzing, what really happens is you're trying to add, subtract,
hmm,
um, different stack, perform different stack operations
hmm,
in such a way that you expect a magic number out of it. And that magic number is capable of crashing a program, which ideally happens because of a bad code, or maybe the memories are not properly feed, or
hmm,
you have a buffer which is not very well structured or defined. So fuzzing in general, like you said the example, right? There's a lock and you just try multiple attempts on it to get out of it. So
hmm.
in general, everyone start from like a normal guy who's not into security to a guy like all of us. We all are doing fuzzing in some or the other way to get that magic bytes out of it. That's what
Right.
actually fuzzing is.
Interesting. So, in my knowledge, actually, we can imagine a program, right? If that's part of the fuzzing process, we can imagine a program which can automatically find weaknesses like hidden backdoors or waiting for crashes to happen. Is that correct?
Yeah, yeah, sort of. Yep.
Okay. So I understand that's the power of fuzzing. But can you tell us a little bit about your experience with fuzzing and why you think it's such a valuable tool? Because as a technique, we are all aware of it, right? Even a script kiddie pen tester as well is aware of the technique of fuzzing. But why is it such an important tool that you have such an expertise over it with high level of success?
Um, so I'll talk about first of all why fuzzing is really important. So see, uh, like for example, DevSecOps, SDLC, or secure development lifecycle of any code. So
Hmm,
what ideally it happens is it does a lot of source code review using automation or something like that.
hmm,
But why fuzzing is really needed is because it explores certain different paths which your some commercial tools are not able to identify. Now they might give that, okay, there is a buffer which is not very well structured or defined, but fuzzing will help you to understand in detail that how it can have been exploited, or
hmm,
how it could have been crashed a program.
hmm,
And it could also help you to chain to find some other bugs. So fuzzing is a concept where you start from point A to a source of a program, which is origin A. You
Hmm.
find a crash. The framework, the tool, whatever you're using for fuzzing, would help you to also identify origin B, C, D, and F. So it's like a chain. So
Hmm.
you can probably take those examples to see how you can exploit them.
Hmm.
Whereas in normal enterprise security or SDLC, it's great to have source code review. I'm not saying it's not, but probably it will just generate a HTML or PDF report out of it where you have to sit and understand what needs to be done and what not. So ideally, even if you have a program or a code which is already going to this process, fuzzing will help them to find more better bugs which are not identified or covered by a commercial software most probably.
Hmm.
So that's one thing. But just a follow-up answer on this, why fuzzing is really important, because let's suppose the heartbleed bug, right? So I give this example. It was CV 2014, if I'm not
Hmm.
wrong, back in
Yes.
2014. So it has a huge landscape, right? Because heartbleed was nothing just a heap-based buffer overflow, where we
Yes.
were copying more than 4 additional bytes to one of
Hmm.
the SSL libraries, and it was just crashing the program. Then it probably people materialized that crashed into exploitability or something. Then it became heartbleed for sure. So
Hmm.
the importance of fuzzing is it gives you a bigger landscape. Like if you're targeting a binary which is deployed across all the platform systems, right? You have a
Hmm.
huge landscape to target. So that's why fuzzing is really important first. And Heartbleed is one of the very basic example right now. Yeah.
Okay. Interesting. Interesting. So, in my knowledge, fuzzing is typically used for programs that handle a lot of user input, right? Like web applications, or it could be file parsers. Because the whole idea, I believe, is to see how the program reacts to unexpected or malformed data. Is that correct?
Yes, sort of. So there are two aspects or two answers to your question. Is first you talk about a web application based fuzzing approach, right? That's also a great way, and it's
Hmm.
fuzzing is fuzzing, right? It's common across web or software. It's both
Hmm.
the same. We try to send out different maybe keywords or patterns in web
Hmm.
to find out a parameter or a directory. Although in the software you will have a corpus. Corpus
Hmm.
is nothing like an input files or a seeds probably.
Hmm.
So we might give more better example in our coming discussion.
Okay.
So these are two different things, right? Um, but um, but yeah, typically what really happens is you try to throw some random strings on a
Hmm.
program or on a URL to get something out of it. So that's what you expect when you start doing fuzzing or in web or in software.
So, are there any specific examples like these types of software that benefit most from fuzz testing? So, I'm just trying to understand, where does the fuzzing technique be used the most? Like, what kind of applications or softwares is it the
Um,
most beneficial for?
So it can be used anywhere. You can fuzz anything or everything right now. It is not really required to have if the program takes an input or not.
Hmm.
You can fuzz user argument based program as well. So let's suppose I have a small C program which expects an input from a user, right? I'm going to punch it on a terminal, which doesn't
Hmm.
require a file or maybe an image file or something like that. So you can fuzz that program, start from there to a commercial softwares like Microsoft Excel, Word,
Hmm.
PowerPoint. You can fuzz all those. So the fuzzing landscape is pretty huge.
Okay.
Whatever software you currently use as of today on Windows, Linux, Mac,
Hmm.
there might be some or the other way or a
Hmm.
component which is
Hmm.
used in that software can be fuzzed basically.
Okay. Okay. So, there must be certain tools that must be used in the process of fuzzing, right? So, fuzzing tools, they start with a small set of data and then keep modifying that data in clever ways. And then they feed it, feed this mutated data to the program to see if it crashes or behaves unexpectedly.
Right.
So, what are like the core functionalities of a fuzzing tool, and how does it iterate the fuzzing process?
So, first of all, there are many different framework as of today. There are,
Hmm.
like, for example, the very famous one is AFL right now. which was ideally managed and maintained by Google, but now there is a fork of AFL called AFL++, and it is really community driven. So most of the people are contributing into it.
Okay.
Then we have other frameworks like Honk Fuzz, we have
Hmm.
libfuzzer, then
Hmm.
we have libafl, something like that.
Hmm.
So I'll be very specific right now for AFL because it's widely used currently, and even there is this project run by Google called OSS Fuzz. They
Hmm.
also utilize AFL libfuzzer as their primary source of fuzzing framework to fuzz any software. So how it happens is in AFL there would be different strategies which AFL utilize to find
Okay.
that magic bytes. So you remember
Okay.
our example, right? It's
Hmm.
nothing, just you have to find out a magic bytes out of it.
Hmm.
So AFL has typically more than 8 or 9 fuzzing strategies like havoc, splits, trim, splice, and etc. These are some strategies.
Right.
Yeah,
So AFL, when you mean you say you're talking about the American
yeah, it's
fuzzy lob, right?
American fuzzy lob. Yeah.
So this is actually one of the most common techniques of fuzzing. If we can just actually give a little bit of context for the audience who don't know what AFL really is in a simpler manner.
Okay. So AFL is a tool right now. It's an open
Mm-hmm.
source tool which was developed by Michael back in 2012 when he used to work with Google. So it was previously known as Bunny the Fuzzer for some reason, I don't know. But then got changed to AFL, which is now American Fuzzy Lob.
Hmm.
Now, this tool is an input based fuzzer basically, or a framework. Framework would be much more preferred name for this, not a
Hmm.
tool. So this framework is capable of fuzzing programs which takes input as a file, or maybe uh, like anything which takes the program which takes as an input. As of today, you can
Hmm.
fuzz it using AFL. Not
Hmm.
just limited to this, but there are many other things which you can explore. But yeah, just to answer in a very basic, it's a
Understood.
framework, yeah, which helps you to fuzz a program which takes user inputs.
Okay. Thank you.
Yeah.
Yeah. So we'll come back to the discussion regarding what are some of like the core functionalities, right, of a fuzzing tool, and that's how we got into the topic of AFL. And you were talking about there are some 9 techniques. So could you go into that?
Yeah, so AFL consists of 9 strategies or 8 strategies as of today. Though there are certain terms, in, those strategies have a naming convention basically.
Hmm.
Havoc, HAVOC, then trim,
Hmm.
splice, bitflip, and etc. So what really happens is, let's suppose some of the strategies will do stack-based operations.
Hmm.
Now, okay, so let me just describe in such a way that you have a program. That program is a JSON parser. Uh,
Okay.
it parses a .json file and gives an output out of that. It's pretty neat, small program, nothing great.
Hmm.
You want to fuzz that parser right now because it has been utilized somewhere, somehow.
Hmm.
So the very first aspect, and this is completely open source based fuzzing right now, whatever we are talking. So what really happens is, first you have to instrument that program with AFL. So when I say instrument that program with AFL is, how would a third party framework, which is a fuzzing framework, would understand that a JSON parser parses a JSON file in such a way,
Hmm.
right? So when I say instrumentation, it means that first of all, you have access to the source code of that JSON parser, and you're going to use your AFL compilers, not the standard GNU compilers. So standard GNU compilers are like GCC and
Correct.
etc. Yeah.
Hmm.
So you're going to use AFL compilers like AFL-CC, AFL-Clang. So these compilers are capable of injecting
Hmm.
AFL environment variables into this JSON parser program,
Okay.
right? So it's like that. So there's a program, it has A, B, and C. So A
Hmm.
is like get a file, B is
Hmm.
like parse that file, and C is like display the parsed output. this is
Hmm.
this is what parser does, right? So AFL, when it tries to instrument it, it will read those functions or methods to understand that I need to flow the malicious or that magic string from block A to B to C,
Okay. Okay.
right? So that's how it understands that this is the flow of my fuzzing would be completely. It can't go from A to C, right? So in a very simple word, when I say instrumentation of a program is, AFL is gonna inject their some sort of environment variables or some magic environment variables to that piece of code, just to understand that A, B, and C are the pattern that I'm going to use.
Okay.
So you instrument a program, that's clear. Second is corpuses. In fuzzing space, we call input file as a corpus or a
Okay.
seeds. So
The
it's a
starting
JSON,
point.
yeah, the starting byte or the starting file, whatever it can be. So it's really interesting, right? So there's a JSON parser. So you are expected to have a .json file. So
Okay.
corpuses plays a very important role when you do fuzzing, basically. Right
Okay.
now, rather than JSON file, if you use IMG file or JPEG file, it's not gonna work.
Okay.
It's really not gonna work because AFL or the program is not able to parse that, right? You're failing the foundation of the JSON parser itself, right? So corpuses are very important to us, and always a best way, which even we deliver this in our workshop or training, is the corpus's size should be less than 100 KB or something, very less.
Okay.
So your fuzzing strategies and enhancement is pretty much fast. So you have a JSON file now, you have an instrumented program, and then AFL will take that file. So let's suppose the file is sample.json and it has a JSON object or a JSON set of data. So it's going to perform some sort of operation, and that operation is like bit flip. For example, if you open that sample.json in hex, and let's suppose there are certain bytes called A, B, C, D, E, F, G, H, it's going to flip it around. It will make A, C, D, E, F, Z, just random
Typo
number.
squatting techniques.
Yeah, it's
Okay.
just like that. And it's going to throw that input to your instrumented program to see how a JSON parser reacts to it and what sort of output is being generated.
Okay.
Right.
Okay.
Yeah. So coming back to the question again, so those 9 strategies are nothing, just one of them. When I say bit flip, right? So bit flip is one of the strategy, basically flipping the bytes of the corpuses and then throwing it. Similar to that, you have arithmetic. The name itself says that when AFL uses arithmetic as a strategy, it's going to add or subtract numbers in that corpus file. It's going to forcefully just add -1, -3.
Understood.
Yeah. And then it will see that how program takes this and generates an output out of it.
Okay. Okay. And is there a role, like, because since arithmetic operations and all are coming into play, like, do powerful GPUs enable the process of fuzzing to happen at a faster rate?
Yep. So first of all, never ever try to fuzz any program on your spare laptops or machines, because it's really not going to work. Power consumption plays a very great important role in fuzzing. You should have a lot of GPU into it. So ideally, we take some random servers, maybe EC2 or something like that. The more the cores, the better fuzzing strategies or the better execution will happen. So I remember when Google started their project OSS Fuzz, they were fuzzing, I think, in 100,000, like 1200 cores, I think, if I'm not wrong. But obviously, they have expanded a lot right now. So cores plays a very important role because you are doing a lot of input-output operations. And in that case, you would require to burn out your whatever you have in your hardware.
Absolutely. Understood. Lovely. So, I think there was a requirement of a vulnerability where fuzzing technique could have actually helped me exploit it, right? And it was around when those image magic RCs started to come out, and when we try to crash the program and we were trying to find out what kind of class is being able to come out of this, right? So even just being able to see the class name could lead to something. So in your experience, have you been able to exploit a vulnerability at a very critical level using fuzzing techniques?
Um,
And
yeah.
if so, could you tell us a little more about those vulnerabilities?
Yeah, so we did this. We figured out a use after free in Vim. Um to be honest, Vim has a lot of huge code base, and Vim is deployed everywhere in most of the common Debian platforms. and people struggle a lot to escape Vim. But yeah, we started fuzzing Vim.
So you
So
are like the true embodiment of never quit.
yeah. So yeah, we started fuzzing Vim and we figured out a lot of crashes. But yeah, not every crashes are vulnerabilities, or not maybe every crashes is exploitable. But yeah, every crashes is like, there would be some. Um, so for example, let's suppose you trigger a crash, but
Hmm.
that specific function is never called on a user level itself. So you can't trigger it in real life,
Hmm.
right? It is doing some backend logic, so you
Back
can't
end
ever,
logic.
yeah, you can't never trigger it. So we, like, I have personally found out those crashes a lot. But coming back to your question, we got lucky finding out one of the attribute, or maybe while when we were fuzzing Vim, we figured out a use after free bug in Vim, where, so Vim has their own regex engine, if you're not familiar with. So Vim is capable of rendering those regex and giving the output to you. So we
Okay.
started fuzzing that, and we saw that there were specific methods or maybe functions
Hmm.
which was consuming a memory. Like for example, the allocated memory was 300 bytes, but the consumption of that 300 was not really like that. It was like 200 or maybe 320 something.
Hmm.
The remaining memory was just a freed memory, right? So
Okay.
this is nothing just to use after free, basically.
Hmm.
So we got lucky, and when me and one of my colleague who really works with me closely in fuzzing space, we
Hmm.
started debugging Vim. Now Vim is a very big code base. If you see, there is a lot of commits which happen, um, because it is deployed everywhere. Start from
Of
Mac,
course.
Linux, Windows. You have
Hmm.
to specifically install it, obviously.
Yeah.
So when we started debugging it, trust me, we just gave it up because we thought it's never going to work.
Okay.
But we took help. We pulled
Hmm.
out a lot of strengths in the community itself, asking for a help, and people were great to help us understand that how we can do so. And we were able to, just in a reverse engineering way, we were able to overwrite EIP or RIPs depending upon whatever architecture you were using, and you can probably put down the shell on the freed memory which we had.
Hmm.
So so yes, the answer to your question is yes. We have one bug. We identified that.
Okay.
Similar to that, we have identified other issues, but most of them were not triggered, as I mentioned. Right, it can't be triggered using some other way. But
Right.
Vim specifically, you can send a crafted file, and if they were using that specific version of Vim, I think this is 3 years old, maybe 2020 or 2021. After
Hmm.
COVID, we started doing this. Yeah.
Okay.
So yep.
Yeah. I'm really glad that I'm not using Vim and I'm using Nano, right? So I know Vim is more hackery in
Yeah,
terms of scripting and all, but I still prefer Nano, and
yeah.
that is one more reason now I got to be continuing that habit.
Yep.
Brilliant. You spoke about different architectures, right? Like fuzzing can be challenging when you are testing it on different types of softwares, and somewhere fuzzing ARM might differ from a traditional x86 base. So how is that process different from architecture to architecture?
Okay, so uh, I have an idea about this
Okay.
because everyone has an expertise. So I'm good in open source and little
Hmm.
bit on Windows. So
Hmm.
my colleague is really good in fuzzing ARM-based binaries.
Okay.
But as per my understand, because okay, so there is no great difference.
Okay.
The reason why, first thing is AFL, the tool, the framework itself is capable of handling or fuzzing ARM-based binaries as well.
Okay.
So the technique remains the same, the fundamentals remains the same. It's just the difference of architecture itself, which framework handles it by some attribute, some sort of attribute, which I don't know at the moment. But yeah, but the foundation remains the same. You have to instrument a program, you have to find a proper corpus, then you start fuzzing it into ARM.
Okay, okay. So, at a different type of architecture level, there is not a major change that comes into play. Like you can understand if you are able to fuzz test one of those architectures, and if you ever come across another architecture, it might be very easy to adapt and fuzz test the
Yep,
same.
yep, yep. because the foundation remains the same for fuzzing throughout. It's
Hmm.
just, so I think you asked one question right initially, that any script kiddies can do fuzzing as of today, and that's yes, they can use it as of today. But the
Hmm.
point is what technique, how they are utilizing their corpuses,
Right.
and how they, which attributes they are fuzzing. That is also important.
Of
So
course.
if you just open Google OS's Fuzz project as of today,
Hmm.
they have compression libraries, they have Curl, they have PHP, Python, and many other stuff, right?
Hmm.
And they fuzz throughout 24 by 7 with their 1200 plus cores.
Hmm.
Uh, so me, as a normal guy somewhere sitting in UAE, when I try to fuzz this with my 32 core GPU or something like that, there would be a huge difference. Like I cannot
Of course.
tackle them. But the
Right.
point is, what we try to understand, or what makes a researcher differentiate with a script kid is,
Hmm.
I'm going to go to that OS's fuzz project and see what attributes they are fuzzing. For example, if we fuzz nmap, nmap can
Hmm.
also be fuzzable,
Of
right?
course.
Because it takes hyphen small I capital L for a text file, and
Hmm.
then you do hyphen A for aggressive or whatever. So let's
Yes.
suppose OS's fuzz is only, although they don't fuzz nmap, but yeah, if they are fuzzing hyphen A as an
Hmm.
attribute,
Hmm.
I'm not going to probably target that, right? That's a typical bug bounty, what you can say, intention.
Right.
Because I know that they are doing it, so I'm not going to get it. Probably
Hmm.
I'll target hyphen capital PN, right?
Hmm.
If the host is up or not, yeah. So the the reason why I gave this as an example is today, even when I fuzz any program, I'm still able to identify crashes, which
Hmm.
OS's fuzz is already doing 24 by 7. The reason why, because the corpuses differ, the technique differ, and what attributes, what set of things they are fuzzing, that differs completely.
Hmm.
Yeah,
Okay. Okay. Interesting. It's been amazing, these techniques, and I think conversing into these techniques can take hours long, right? So,
yeah.
um, for those interested in learning more about fuzzing, what kind of resources would you recommend to get started?
Okay. So what you can do is just like DVWA,
Hmm.
when I started security, we had damn
Yeah.
vulnerable web application. So
Yeah.
I think there are certain C programs out there
Hmm.
which people have made vulnerable by itself. I think Fuzzgoat is one of the GitHub repository
Okay.
where it has multiple vulnerabilities and a detailed step of how you can fuzz those programs. And
Okay.
that brings me to another thing. GitHub, as a company, they have their own fuzzing team. And
Hmm.
I think there's this gentleman, I cannot recall his name right now, but he is a lead researcher or something into GitHub. So in
Hmm.
his personal GitHub repositories, he has 10 different examples of how you can fuzz VLC to Chrome to TCP dump and many
Hmm.
other stuff, right? So I think that's also a great resource if you want to start fuzzing, because he has a CTF and then he
Hmm.
also got hints somewhere.
Right.
Yeah.
Right.
So you mentioned, right, fuzzing requires a lot of patience. And
Hmm.
this is one of our very first slide when we give training or workshops, right? Because fuzzing do requires a lot of patience. There
Hmm.
might be a program which takes to identify a crash maybe within like 6 months, 8 months, and etc. But there would be a program which can give you a crash within 5 minutes, 10 minutes, depending upon how it has been written.
Hmm.
Was it been a target to someone previously? They have fuzzed it or not?
Hmm.
So this is the success mantra, right? Fuzzing is equal to patience. You require a lot of patience to find out a crash.
Right. Right. Great. So that's it from our end. We saw how fuzzing is a powerful tool in the cybersecurity arsenal, and it helps developers build more secure software and protecting users from potential vulnerabilities. And I think, as Dheeraj has shown today, that fuzzing can be both fascinating but also complex. It's not just brute force. Brute force is very different,
Yeah.
right? So, but yeah, by understanding its core principles and leveraging its capabilities, I think we can all play a role in creating a more secure digital landscape. Uh, Thank you, Dheeraj, for sharing your expertise on fuzzing.
Thank
And
you.
We'll be back with another exciting topic on the next episode of That One Sec Guys podcast. Until then, stay safe and stay curious.
Thank you. Thanks, Harshil.